Hi, this is Steve Michelotti from the Azure Government Engineering team. Today I'm joined by Jamie Duncan from OpenShift, and we're going to be talking about OpenShift on Azure Government. Welcome, Jamie.
Hey, good morning. How you doing?
So I guess we should just start out by telling us all a little bit about what is OpenShift.
Yeah, well, it goes a lot of ways. OpenShift is a lot of things to a lot of people, and it's hard to go in there. The best definition I can come up with is that OpenShift is Kubernetes, which is one of the biggest buzzwords in IT, one of the most popular open source projects out there on the planet. OpenShift is an application platform that's enterprise grade, that Red Hat comes with all of Red Hat's support, all of Red Hat's efforts, with Kubernetes as its beating heart. So it's an application platform that has all of that flexibility, that's leveraging containers underneath to give you your applications.
Okay. All right, so let's go into a little bit more depth. Often we use this in CICD pipelines?
All the time.
Okay.
And that's where it's supposed to, that's where a lot of that power is. We talk about automation, we talk about all of these great fun things. And if I had to build out 15 virtual machines every time I wanted to launch a CI/CD platform, my dev and stage environments would have to be massive. We just don't have those resources. We always have to figure out how to do more with less. We have to isolate our processes more effectively. So as more things become more CI/CD'd, almost like a buzzword, almost like a verb, that I've CI/CD'd this application. Yeah. We have to figure out how to do it in the tightest possible way, in the fastest possible way. If I have an application that takes 10 minutes to build, I can't wait 45 minutes for my VMs to provision. Yep. I can't have that overhead, that operational overhead, taking a ton of time. In containers, where virtual machines spin up in minutes, containers typically spin up in milliseconds. Right. And where we can spin up 5 or 10 or 20 on a given hypervisor, inside a single virtual machine, I can run 50 or 100 containers, depending on what the application is. Okay. So we just get that economy of scale with that economy of speed that makes CI/CD way more practical. All right. Back of those heady days of I'm going to launch my build and then go have lunch, we don't have to do that anymore. Right. It's great times. So yeah, so all of that, containers and Kubernetes and OpenShift, really makes CI/CD more practical. Okay, great. For way more applications. All right, so what else should we talk about to set up our eventual demos here? Yeah, so we have a couple of demos that we're going to do today. Anytime I do a presentation, I always have to have a little good luck charm. I always stick a little about me slide in because it's fun. I've been at Red Hat about 7 years. I've been working with our government customers that entire time. So the customers, the people that consume Azure Gov, I've worked with every major government agency out there. And one of the things I really like to think about, the way I like to talk to my customers is I try to be that long focused lens. I try to find customer problems in the healthcare industry, in the healthcare, CMS and the NIH, and figure out how those problems are affecting what's going on in Homeland Security, and figuring out how it's going on in other civilian agencies or DoD agencies, and try to be that long focused lens with the breadth of experience. 7 years in the government is kind of like dog years. Right. I always take a picture of my daughter Elizabeth because she is the cutest thing on the planet. This picture was from last week when she was showing us all how to wear sunglasses. It's just fun. And then a little bit of a shameless plug. Yeah, she really is that cute. A little bit of a shameless plug. John Osborne and I, another solutions architect inside for Red Hat Government, we have a book about OpenShift out, 320 some odd pages, where we actually, it's the first time someone tried to talk about the developer experience and the operations experience and OpenShift and Kubernetes all under one set of covers. We go all the way down to the bottom of the kernel, and then we come all the way back up to the top of the application stack, including a really complex CI/CD pipeline in Chapter 6. Okay, which is kind of the impetus for this first thing. OpenShift is enterprise Kubernetes. That's what we just talked about. It's using that beating heart of Kubernetes, all of that power of that massive community that's growing. It's consistently one of the top 5 open source projects on the planet. Massive growth, massive amount of work happening. We're taking all of that and we're putting the extra pieces on top of it to make OpenShift that makes it an enterprise consumable product. We test OpenShift up to 2,000 nodes. So you can have a 2,000 node OpenShift cluster and Red Hat's going to support it for production outages. It brings in a routing layer to make it easy to get in and out of your applications from outside the cluster. Kubernetes doesn't come with that. Configures a software-defined network for Kubernetes to use. Kubernetes doesn't come with one out of the box. So we take all those things that makes Kubernetes hard that you see on Twitter, and we just make it work out of the box that way.
Gotcha.
So that's kind of what OpenShift is.
So it's taking all the goodness that we already have in Kubernetes and sprinkling some OpenShift magic on top of it to make it even easier to use.
Yeah, exactly. We make it so it takes an hour to deploy, not 4 days.
Yeah.
In fact, I'll be doing a deploy later this week, and we're planning on about an hour for a production-ready cluster.
Okay, great.
It's good stuff. But all of those bits, and computer geeks like us, we always get obsessed with the new shiny.
Right.
And we go into our customers and we talk about the new shiny, and we might get them excited about it, but we're not really helping them bring value. We talk about projects that are months or even years away from being ready to be deployed in a data center for the government.
Right.
And I try not to do that with OpenShift. I try not to do that with containers. There's so much power there that we do it, that we can bring that value and we can make their lives better. And at the end of the day, whether we're talking about DevOps or CICD or whatever buzzword we want to use, we have to help them fulfill mission. We have to help them make their job easier. You know, I threw a couple of bullet points up here. We have to make the dev or the ops guys' lives better.
Right.
They have to be able to do more with less money. I've talked to, and I'm sure you have too, hundreds of government customers in the past year. Nobody has a bigger budget next year than this year.
Right.
So we always have to do more with less.
Right.
We have to streamline workflows. Automation is the only way we're going to survive these days. And CI/CD is really just really complex automation.
Right. Yeah, we talk about how can we spend taxpayer dollars more efficiently.
Exactly.
How can we focus, enable the mission, focus on the mission. And yeah, as a developer, I like to get up there and talk about slinging lines of code, but the reality is it's not about that. It's about how you can bring those efficiencies to the customer.
This awesome algorithm I wrote doesn't matter.
Yeah, no one cares about it.
If it doesn't fulfill mission better, if it doesn't save us money in the long run.
Yeah.
Just being awesome isn't good enough anymore.
Yeah.
So that's really where we like to focus on. So the first demo we put together is, when I think about value, especially public clouds like Azure, the ability to bring as many different kinds of workloads into them without having to drastically change those workloads, to me, is a huge value proposition. Definitely. And the first one is that legacy app. And people talk about it all the time. There are entire books written about how you can't bring a legacy app into a cloud-native world, into a cloud-ready or a public cloud provider. And you really can. If you can get the app to run in a container, you can bring the entire thing inside OpenShift into Azure, even if you have requirements that aren't great. If you have like I ran into this just a few months ago. A customer had literally a hard-coded requirement for NFS in the application. They couldn't not use NFS. And NFS, we all know, is a great tool, but production is not its middle name.
Yeah.
So even if you have those hard-coded requirements, even if you have really complex deployment processes using multiple different third-party tools, which is what we're actually going to be doing here, you can bring all of that into OpenShift. All of those toolings, all of that tooling runs in.
This is a super important use case, especially in the government space. Of course, it's nice if you can rewrite your application to use all these great cloud-native bells and whistles, but the reality is that government customers and agencies get pressure to get your stuff to the cloud right now.
Yes.
How can we do that? What does that mean?
Yeah, every single government agency has a public cloud policy now. And if they're not serious about it, it's just because they don't know how to be serious about it. Yeah. Because they have these legacy apps. So the first demo is this, it's a Java app. It's a monolithic designed app on purpose. We're using Jenkins. We're using SonarQube for QA testing to actually run the testing. It's using Nexus as its artifact repository. The source control is in Git. We're using Gogs, which is this containerized Git repository, GitHub clone, essentially. All of that is deployed in OpenShift. Awesome. So let's trigger this workflow. I'm going to do literally a Git push from my laptop into an OpenShift cluster running on Azure Gov, and we'll watch the pipeline build out.
Right. Great. Right. Yeah, this is a great example because here you have, of course, Azure Government with, you have an environment, you need compliance and whatnot, but you have the OpenShift goodness just sitting right there in your compliant environment. Yeah,
so I'm able to abstract away some of that cloud nativeness.
Yeah, definitely.
And bring in and insulate my legacy workloads using tools like OpenShift.
Cool.
So I am miles away from being a Java developer. I'm an old ops guy, but this is also, I just want to say, I'm a laptop Linux user for a long time. This is VS Code. VS Code's pretty awesome. We were talking about it before we started filming. I may be a convert to VS Code, even on Linux. VS Code has
quickly become the most popular Microsoft open source project out there.
It's pretty awesome stuff. So we'll save this off. I just commented out an ignore clause, an ignore decorator. So we're actually going to run this test. And I'm really just looking for something. All right, to do that, and then Control S.
You're going to push your code?
Yeah. So we'll add all of our changes. We'll give a message.
Yep.
We'll get a good comment, getting rid of ignore decorator.
There you go. Good citizens there.
Exactly, yeah, exactly. And then we'll commit our code.
Yep.
And then we will push.
Great.
It's going to ask me for my username. All right, now we haven't looked at OpenShift yet.
Yep. All we've done is make a simple push.
Exactly. This is the front page of OpenShift.
All right.
Let me get rid of this little filter here. So here I have all these buttons, all these different things I can do. But I also have this CICD project that I created. And I did create this ahead of time, a little infomercial style.
Right.
And you see here are all of my applications. I have GOGS, which is our source control for today. And it's just a GitHub clone.
Okay.
You can see here, getting rid of ignore decorator. There's my Git push. So from my laptop sitting here in Redmond, Washington, this went out to the Azure Gov Cloud and got committed. So that part worked.
Awesome.
So we're good to go so far. We have Jenkins running. If we look here, we have a Jenkins build pipeline going already. And this is going to take us a couple of minutes because it's going to pull down some information from the get-go.
But what I see that is, I hope that is obvious to people right off the bat, is that we're running all this in Azure Government. This is just a legacy application.
Yeah.
We didn't force you to use SQL Server or .NET or C#.
We didn't do
Java.
any of that.
We didn't force you to use VSTS. It's running Jenkins. You're taking your existing solution with your existing tools and platform and doing all this, right?
This is pure raw JDK. This is
awesome.
Pure Java, no frameworks or anything that I'm aware of.
Great.
So you see it's building the app now. So it's got to pull down some information because this is the first time I've built it in this project. So just kind of walking through what's going to happen, we're going to build the app. So we're going to build the Java application, run through, put all the artifacts into Nexus, pull them out, do whatever needs to happen, build a container image that has my application. We're also going to run through, use SonarQube to test all of the code.
Okay.
And there, show our test coverage, do all of those things.
It's happening right now. You checked in the code and the CICD build is running.
Yes, so it is running in the background.
Okay.
Here's Nexus, our Nexus repository. It's doing all the stuff that it's doing. We haven't quite gotten to that step yet. I jumped the gun a little.
Okay, that's fine.
Here's SonarQube. SonarQube is one of those apps that didn't exist when I was an everyday admin, so I'm kind of stunned that there's a tool to do all this awesome code checking. But again, all of this is running inside OpenShift, so all of this is container ready. These are off-the-shelf components. So I can bring my environment in, drop these legacy apps, and run them against these CI/CD tooling products that they've been out there for ages.
Awesome.
So I can bring very complex environments very quickly into OpenShift.
Okay.
All right, so our application is built, or at least it's further down through the pipeline now. Let's go see what we've got done so far. So we've built our application. So we've built a container that houses our application. We've built that container on the fly. No Docker files, no anything, no knowledge of really even how a container works.
Yeah.
We just took our application, we took Maven, and we built it all together using a templating technology that's inside OpenShift that just works out of the box. We ran our test suite against it. We ran our code analysis against it with
I see the test. Looks like the test just took 13 seconds.
Yeah.
All right, great.
We're on our full unit test suite. Code analysis took 29 seconds. We've archived our app, so we've archived it into Nexus. That took 10 seconds. Now we're creating our image builder. Now we're getting ready to actually deploy our application into another project.
Okay.
So this particular pipeline will deploy into what we call a project inside OpenShift, which is just a logical separator. It's going to deploy into a dev environment.
Okay.
Where our app will be up and running.
Awesome.
And then it's going to actually prompt us, once we go look at our app and running the additional human tests we want, we click a button, and now it's actually creating the dev environment.
Okay.
And then once we decide that dev is okay, it's actually going to deploy to a staging environment for us.
Okay.
So we have a full CI/CD workflow inside here, inside of 3 minutes.
Okay. Awesome.
And all of the times are down in here. So now that all these tests are done, like we can actually go look at SonarQube. And we can see if our test passed. So we have one project analyzed. It found 2 bugs with 1 vulnerability, and 17 things didn't quite smell right.
Yep.
But if we look at our project that got analyzed, I love the fact that it says code smells.
Yeah,
exactly. It just makes me laugh. We found 2 bugs. We can go in and see what those bugs are. These are pretty old ones that aren't going to get fixed in this version of OpenJDK. 17 code smells. We got an A. We don't have great test coverage, but we'll get there.
Yep.
That was the thing that I commented out to actually run some tests, to do some test coverage. 0 duplications, and it's 2,000 lines of code.
All right, great.
None of that existed. So we did all of this on the fly.
Okay, so the deployment's still happening right now?
Should be done by now.
Okay.
We've created dev, and we've deployed to dev, which took 0 seconds.
Awesome.
And now it's actually waiting on us to see if we want to deploy. And again, this is visualization of Jenkins inside. So we can go look at, now we go look at our dev environment. Tasks, this application's name is OpenShift Tasks. Here we are. And OpenShift deployed my application, gave me and built me a route into it. So it gave me a URL to go look at my application automatically.
Cool. Okay.
Yeah.
I like that. Yeah.
Yeah, all of it's just done. And at the end of the day, what does a developer want?
Yeah.
Developers don't want to be root on Linux servers. Developers don't want to have to go be bad admins.
Right.
Developers want a place to write their code and a place to push it and a URL to go look at it.
Exactly.
That's what the rest of it, they just want to be automated away.
Exactly. That's awesome. Okay, so we took a legacy app and we deployed it using OpenShift.
Exactly.
In a matter of 4 minutes.
Exactly. 3 minutes live.
Okay.
Having never deployed it into this OpenShift cluster before.
Okay,
and
great.
here it is. The app is up and working. We can click all these buttons. These things actually send stuff into log files. We can go, it's a unit testing tool. We can generate load against our container for however many seconds we want. But we say, okay, the app is done. We've decided dev is okay. Dev has passed all of our user acceptance testing. We still have that pipeline running. And it says input required. My pipeline is paused now. And it's going to pause until, just like Jenkins, this is a Jenkins pipeline.
It's like a workflow.
Yeah. And I have Jenkins integrated with the same authentication that my OpenShift is using.
Okay.
Sometimes this login takes a few seconds, but we're there. And I'm ready, promote to stage. We don't need to remember that password.
Okay, great.
I just
and
click promote.
The choice right here.
Yep, and there it is. And I have Jenkins is deployed, and we see the actual pipeline working if Jenkins is an environment you're more familiar with. And it's done. We go back and look at OpenShift. It's deployed to stage.
Nice, 4 seconds. Okay, sounds good.
So anytime I do a git push, all I have to do is push my code and that pipeline gets built out.
Okay.
That idea of CICD, that would take a huge amount of resources to do inside a traditional environment. And if we look inside our application, we have our metrics deployed. The Git server is taking 51 megabytes of memory off of my system right now.
Can't complain too much about that.
Exactly.
Right.
When was the last time you built a VM that had 51 megabytes of RAM in it?
Right. Okay, cool.
Just that loss of overhead.
Okay. So we deployed the legacy app. What are some other types of apps we can deploy?
Right. So the other value proposition, and we'll talk a little bit about that future-looking kind of cloud-native 12-factor thing here in a minute. But a huge portion of the work that we do, the work that our customers do in the government, I just call them simple applications.
Yeah.
They don't have these giant CI/CD workflows. A team of 1 or 2 people wrote them. They keep them in a version control system. They update them once every 6 months, and they just update them.
Yeah.
This is actually an example that we used from the book. I have pulled up here. A simple image uploader. So I have literally just a Git repository. This is a PHP application that I think is maybe 1 page, and it lets you select a box, you pick a picture, and you upload it into it. Done and done. We'll clone it here. This is GitHub that everyone should be familiar with, especially people at Microsoft.
Oh yeah, we love
You guys
GitHub.
know a little about GitHub? Yeah? So let's go. We'll deploy this completely from scratch.
Okay, so different application. This is no longer a Java application.
No, this is a
Different
PHP app.
PHP app. Okay,
Yeah,
great.
We'll create a project. We'll create one of those logical separators. We'll call it Image Uploader.
Okay.
Image Uploader app. And click Create. We can go in there. I haven't deployed anything.
Okay.
So I can browse our catalog, and that's where this catalog comes in, and we'll come back to what the catalog can do here in a few minutes. But I can browse by language, and go to PHP, and I can have what we call a builder image. A builder image inside OpenShift it's PHP and the web server, and when you tell it the source code to put in it, there's a little bit of JSON in there that it knows where to put the source code to deploy it so it functions.
Right.
Sort of a quick start. So we just tell it it's PHP. We tell it which version of PHP we want to use. We give it a name. uploader, and we tell it the URL that we pull from.
So I just given it a Git repository right there.
That's all the information you need.
Other than our pretty display names.
Yeah, exactly.
Okay.
And I click create. We'll go to our project overview. Now, this one obviously could take a couple of seconds to build the first time. We can actually watch it in real time. We can watch it download everything. It's going to pull these files in. It's going to take that builder image. It's going to take my source code. It's going to make a custom container image from them.
Kind of standard container functionality.
Exactly. And then it's going to take that custom container image and push it into the registry that's inside OpenShift that comes out of the box. Another one of those great little value adds that Kubernetes on its own doesn't come from. And it's done.
Okay. Now, do you have configurability of where the container registry lives, or that's always the OpenShift registry?
By default, it's the OpenShift registry. It can be an external registry like Artifactory, or
it could be Azure Container Registry
if you want it to
be. OpenShift registry.
Exactly.
Your choice.
You can tell OpenShift where to look.
Okay.
But we're gonna our sane default is we're gonna have one running internally.
Makes sense.
And there are a couple of bits and hooks in there that work, but you can configure all of that. You can look at external. You can look at 15 or 20 different registries depending on what your people do.
Awesome. Okay.
So this app built even before you asked the question.
Okay, great.
So, and it also gave me a URL to go to.
Love that.
Exactly. Click the button, and there it is. I'm not a front-end web developer, so you'll forgive my shades of gray. But I'll pick a file. Here's our picture of Elizabeth swimming. Here is Elizabeth holding some big giant foam swords. Most of my pictures are Elizabeth related. And it's done. Okay, File's uploaded.
And where did it upload the file to?
It uploaded it by default. It uploaded it into, get rid of our picture of Elizabeth here. It uploaded it to the ephemeral storage that's inside the container.
Okay.
But I can add persistent storage to a container after I deploy it.
Okay.
So just by simply clicking.
Or you could even add it to blob storage if you wanted to. It's really your choice.
So with OpenShift,
it's just code.
Blob, not quite there yet.
Okay. But you could just write like PHP code.
I could go directly to the API.
Storage.
Exactly.
Yeah, exactly.
By default, out of the box, Kubernetes has plugins that work with Azure Disk and Azure File.
Yeah.
So I can use the Azure File Store, or I can create Azure disks dynamically on demand, and attach them to the hosts that are my containers are using, and then present them into the container. And all of that's automated.
Cool.
By default, so I've already provisioned some storage. So I can just go right here to Uploader, Actions, Add Storage. Oh, hit the wrong button. We don't need to auto-scale this application. Although that's another
interesting feature.
Another fun feature,
we'll add storage.
Yeah, so we have what we call a horizontal auto-scaler. So create a storage. We'll call this one Image Uploader. I have multiple ways. Different storage providers have different types of different abilities. Mm-hmm. Obviously, the Azure Disk Storage, I can't present the same disk to two VMs at the same time, so I can't present it to two containers at the same time. Yep. So it can only do read-write, single user read-write. Other technologies I can have where I could attach it to 50 containers across 50 hosts, so I can do read-write many, just depending on the technology. We'll do single user read-write, and we're not going to do a whole bunch of pictures, so we'll just say 1 gigabyte, easy peasy. Click create. I go to storage now for this project. I can see that image uploader storage request. And there's this concept inside OpenShift of separating the request for storage, which is part of my application, from the actual storage, which is part of the control plane.
Yep.
That separation of concerns, that kind of DevOps mentality, is inherent in everything that OpenShift and Kubernetes does.
Great.
So already, I had an available storage volume that met my capacity and my storage type requirements, and it mounted and it bound it to that storage request. Okay,
so those were a couple of awesome demos. What can you tell us about some of the Azure integration we have with OpenShift?
Yeah, so a lot of that it's actually pretty amazing. So we talked, for the most part, we're talking about legacy apps and these everyday applications, these smaller applications. But the way we're going to be deploying apps, the way we're going to be building things out over the next few years is really that 12-factory microservice, take our code and integrate it with multiple, managed services to get our job done.
Yeah.
We don't want to have to write a search engine because you guys have a search engine. We don't want to have to manage a Postgres database because you guys provide one, or a Cosmos. Yeah. All of that is integrated into OpenShift out of the box. In this environment, this one I deployed on Azure Gov a few days ago, I deployed what's called the Open Service Broker for Azure.
Okay.
Took me about 15 minutes. You know, it's a follow 5 or 6 steps instructions, drop some stuff in the command line, and it was done. And you can see here, when we did the earlier demo where we deployed the PHP application, I had that builder image, and I was able to click on it and follow the instructions. Well, we have over 100 other applications that we deploy from. There's a bunch of JBoss stuff that comes out of the box, Node.js, databases, all sorts of fun stuff, Ruby applications, different databases, all these things that we do out of the box, a bunch of .NET Core stuff, and all of this just comes with OpenShift.
Yeah.
So all these builder images, all these quick starts, all these very templated, automated deployments. What the Azure Service Broker does, and I'll just filter down on the word Azure, it gives me a bunch of services that are in Azure Gov that I can deploy from inside OpenShift. And more importantly than deploy from inside OpenShift, OpenShift is now aware of them.
Okay.
So that they become part of my application's lifecycle. So that if I need to make changes to, say, the Azure Search, if I deploy that as part of my application's ecosystem, I can now script changes into Azure Search because OpenShift is aware of how to interact with the part of the Azure API that creates and modifies search for me.
So it almost becomes like a part of your solution manifest, so to speak.
Exactly.
Okay.
Yeah, and
makes sense.
All of those things become part of my ecosystem for my application. Okay. The Open Service Broker for Azure, OSBA, you guys need to work on the acronym a little bit. Because something that's a little more pronounceable than OSBA.
Right.
But we'll get there.
Yeah.
Is a little new. So some of this is still in the off. Some of these options are still experimental. I think search is among them. But Cosmos DBs with different APIs. So I can deploy a Cosmos DB and use the Mongo API or the SQL Server API. All of those, it's aware of all of those changes. And then I can just take that application. So if we want to deploy a Cosmos, tell it what I want it to do, tell it which project I wanted to add it to. So that image, if my image uploader, if I wanted to stop writing them directly to persistent storage, I want to put them in a database.
Yep.
Deploy it into the image uploader application. I select all those options that Azure needs for Azure to be able to do its job correctly.
It's basically connection information, if
exactly.
I understand this correctly.
Exactly.
Okay.
I create a secret inside my application that contains my connection information, so it's encrypted, and that's it. And then I click the create button, and I'm off to the races.
Sounds good. Okay.
And it's all that easy. We take that stuff, that hard stuff. That would take a lot of coding,
right?
To code against that API, and then I'd have to learn how to code against the API.
Yeah.
I just need to point and click a few things. Let me go fulfill mission. Let me not have to learn 50 new API endpoints this week.
Okay, great. So we've been talking about OpenShift. We talked about deploying legacy app, even just deploying an app from GitHub that wasn't legacy, as well as integrating with server broker functionality, all on Azure Government.
Exactly.
Okay, great. Well, thanks for joining us today.
Yeah, thanks.
This has been Steve Michelotti of the Azure Government Engineering Team, here with Jamie Duncan from OpenShift. Thanks for watching.